Hello friends, today we are going to discuss about the study of basic comparator. What is the comparator? As its name suggests, it compares the two values. Am I right? It compares the two values, and we are in the electronics department, so we are should be compare the two signals here, right? So for the comparator, here we are using the basic op-amp circuit for this comparator construction. Okay, so how the op-amp is, the op-amp is like the basic op-amp diagram is like that. One terminal is an inverting terminal and another terminal it's called as a non-inverting terminal, and one output terminal is there, one for VCC and one for a VEE. This is the basic op-amp circuit. For the basic op-amp circuit, here we want to provide the two clamping diodes. The clamping diodes are useful for the protection of the complete op-amp from the damage due to the excessive input voltage which is provided to the this op-amp. Okay, so after that, for further construction of the circuit, the one terminal is the output, and there are we should be provide the two resistances. Okay, so there are the two terminals are provided to the op-amp. One terminal we are provided as a V reference voltage, and another terminal we want to provide the analog time varying signal, that is the V in. Okay, so V reference, it means that the we want to keep this voltage at a reference, and we take this reference voltage as a 1 volt, and the time varying input signal is provided to the non-inverting terminal, that is the positive terminal, right? So time varying signal is provided to the non-inverting terminal. It means that this comparator is a non-inverting comparator. Why? Because we provide the time varying signal to the non-inverting terminal, hence we call it as a non-inverting comparator. Am I right? Okay, so next condition is that I want to take its output from across the load resistance RL. Okay, so this is the basic diagram of comparator. Three conditions in comparators. First condition, V reference is greater than that of the V in. First condition. Second condition, both should be the equal. And third condition, the V reference is less than that of the V in. Okay, so as we seen in this the diagram, here we can conclude that initial condition is that V reference is greater than V in. V in start from, sorry, we want to edit that, it is the V in. Okay, so V in is start from the 0 volt and V reference is 1 volt. It means that first condition, V in is less than V reference. At this point, so it is the maximum voltage is provided at a V reference, because the 1 volt is provided here and the 0 volt is provided here. So this comparator, then it's act as a inverting comparator. It means that the waveform start from inverting things. It means the from negative terminal. Okay, so it is the minus Vset system at which the V reference is greater than that of the V in at this point. Okay, so after that the signal is analog signal. Here we have the input signal is the analog input signal. As the input signal is increases, it crosses the V reference at the point at which the V reference is equal to the V in. That is our second condition. V reference is equal to V in. It means that the V in then the 1 volt and the V reference is also then the 1 volt. At this condition, the point is going to the positive, because the point is crosses the V reference, because the balance is happen there. Okay, our next condition is that the V reference is less than the V in. It means that the V in should be much more than that of the 1, that is the 2, 3, or much more it should be the. So at this point, the V in is greater than that of the V reference is this area. Okay, this is the peak signal. At this system, we get the positive output signal. Why we get the positive output signal? Why we get the non-inverting signal? Because the input is larger at non-inverting terminal as compared to inverting terminal. Okay, V in add the positive, hence we get the positive output. All right, this is the condition I show here, that is the V in is greater than that of the V reference. And we hang the analog signal, then analog signal is again dropped down, so it again dropped down below the 1 reference, means the condition number 1 to 3. As we proceed here, the condition number 3 to 1, again we want to go reverse during the negative half cycle. Okay, so condition number 1 to 3, condition number 3 to 1. Okay, so conditions are as follow that, and followed by the our output signals is as follow. Okay, so for this system, the comparator is also called as the ADC, that is the analog to digital converter. Okay, why it is called as analog to digital converter? Here we see the waveform. Here we provide the analog signal, that is V in. We get the output system as a digital signal, hence we call it as a analog to the digital signal converter. And also it also call it as the voltage level detector. We also call it as the voltage level detector. Why we call it a voltage level detector? Because at this system the V in is greater than V reference. We compare it, it means that we find out the particular value. Here I put the 2 3, right? So we find out the particular value by the peak value of this, so we detect the voltage. Okay, so hence we call it as a voltage level detector 2. Thank you.